Assalamualaikum and selamat sejahtera. My name is Muhammad MIKHAIL bin AZROL HISHAM, MH19037. In this video, I will explain about our development of electric vehicle charging infrastructure project. For our supervisor is Dr. SUDHAKAR and the other members is AHMAD RAZIQ, DZAR, DANIAL AZHAD and AHMAD FARHAN. Let's proceed for our introduction. For our project background, a charging infrastructure, also known as an EV charger or electric vehicle supply equipment (EVSE), is a piece of equipment that provides electrical power to plug in electric vehicles for charging, including hybrids, neighborhood electric vehicle, truck, buses and others. Although batteries can only be charged with direct current DC, most electric vehicles have an onboard AC to DC converter that allows them to be plugged into a standard household alternating current AC electrical receptacle. Low cost, low power public charging station known as AC charging station, will also provide AC power. To enable higher power charging, which necessitates much larger AC to DC converters, the converter is built into the charging station rather than the vehicle, and the station supplies pre-convert DC power directly to the vehicle, bypassing the vehicle's onboard converter. These are referred to as DC charging station. The majority of fully electric vehicle models can accept both AC and DC power. Connectors that conform to a variety of standards are provided by charging station. DC charging stations are frequently outfitted with multiple connectors in order to supply a wide range of vehicles. Typically, public charging stations can be found on the street or in retail shopping centers, government buildings and other parking areas. So let's proceed for our problem statement. For our problem statement is first to find a suitable location to place the station, the lack of energy for fast charging, high cost to build the station. The objective of our study is to identify the performance of the station system to enhance the capabilities of fast charging. So for our project scope is research is made based on a charging mechanism to develop charging infrastructure, which has made some procedures and several ways to accomplish this research. All data and results are being concluded and analyzed. So I will pass to the next person. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ABDUL bin Muhammad Idris, matric ID MH19043. So today I'm going to present about chapter 2, literature review. First of all is about solar panel. This is collection of photovoltaic cells that are put in a framework for installation. It creates direct current electricity by utilizing sunlight as source of energy. Photovoltaic modules convert sunlight into electricity. Voltage and current of the module are used to calculate the module's power. Most photovoltaic modules include MC4 connectors on the outside for weatherproof connection to the rest of the system. Next is types of charging. There are 3 types of charging. That is level 1 charging, level 2 charging, level 3 charging, which is DC fast charging. For level 1 charging, it uses a 120 volt AC outlet and can simply be plugged into standard electrical outlet. EVSE Tier 1 cable has a standard household 3-pin connector on one end for vehicle standard J1722 plug and connectors. Charging rates range from 1.4 kW to 3 kW and take 8 to 12 hours. For level 2 charging, most level 2 installed in residential, public parking, etc. needs to be installed and can be charged from a 240 volt AC plug. The charging power is 7 kW to 22 kW and take 1 to 11 hours. For level 3 charging, which is DC fast charging, it requires installation as well as 480 volt AC for DC ports for charging. Charging rate of 43 kW to 100 plus kW with a CHAdeMO or CCS connector and take 20 minutes to an hour. Types of EV plug. There are two types of EV plug, that is AC charging and DC charging. For AC charging, there are two types. Type 1, single phase standard plug for American and Asian electric cars. It charges up to 7.4 kilowatt. For type 2, it has triple phase plug that considered industry standard. It runs vehicle quicker than with 3 additional wires to allow current to flow through. It charges up to 22 kilowatt in popular private area while 43 kilowatt in public charging station. For DC charging, also have two types, which is type 2 and CHAdeMO. For type 2, CCS plug is a 5-pin plug that is improved version of type 2 plug. 2 extra power contacts for fast charging and AC-DC charging powers levels up to 70 kilowatt. For CHAdeMO, it is 10-pin connectors used in fast charging station. It capable of supplying up to 50 kilowatt power with a current up to 25 ampere. For charging infrastructure, for station side, it has one or more EVSE port at the same address. For EVSE connector, it have multiple connectors but provides the power to charge only one vehicle at a time. For connector, it multiple connectors and connectors types CHAdeMO and CCS available on one EVSE port but charge only one vehicle at a time. That's all for me. Thank you.
My name is Danial bin AMALLUDDIN, and I will continue in chapter 3 methodology. So in this chapter we will show how the procedure will be taken. So let's go to the next slide, which is the design carport sketch. We have 3 design, which is design number 1, 2 and 3, and each of them has their own criteria. So let's take a look where the material that we used for design number 1 is wood, while design number 2 and 3 is stainless steel. So the ventilation part is design number 1 and 3 has a ventilation, while design number 2 doesn't, and the space needed the most is design number 3, while design number 1 is the less. For the number of car that can be parked at one time is design number 1 and 2 has only one, while design number 3 cars can park many as possible. And the last part is rainproof, where design only design number 2 has a rainproof system. So let's go where the selected design, which we choose is number 3, because the car the ventilation is open air, so the car will not overheat while charging, and the space is actually not needed too much because it can put many cars at one time and can be charged. So it is also low maintenance because of the stainless steel. The stainless steel is uses because it will not rust in a long time. So the parking size that we choose is the Malaysia because it has the biggest dimension than others. So I will pass it to Farhan to continue. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FARHAN bin FAUZI, and now I will present about material selection. First is solar panels. These panels convert photons from the sun's rays into electricity using photovoltaic PV technology. The energy source for the charging station will be these panels. The total solar panel needed to create 20 kilowatt power output are 40 pieces, where each pieces obtain 500 watt. Next is solar inverter. Solar inverter are one of the most important parts needed in the charging system. It makes solar panels to power up the electronic devices by converting to DC into AC. Inverters are used as the output power of solar panels, which is constantly fluctuating over the day and the weather. All inverters for solar panels include an MPPT solar charge controller that solar production will optimize because of the fluctuations. Next is solar controller. It will regulate the power output of the solar panel and properly charge the battery. There are two types of solar charge controller, which is the pulse width modulation PWM and maximum power point tracking MPPT. Next is type 2 charger. Type 2 charger is the best type because the maximum voltage is 480 volts while the maximum current is 300 ampere. Cars have a standardized male vehicle vehicle inlet, whereas charging stations have a female outlet, either directly on the charging stations in exterior or via a flexible cable with a permanently attached connector on the road. Next is battery. The battery is for battery storage is PV energy. It is the key to autonomy. The batteries that are recommended are lithium batteries. Even though it is more expensive than lead acid, the lithium are perfect for intermittent charging and long-lasting, and it lasts up for 10 years. Alright. The time taken for electric car to charge from battery. First, level 1 charger, 20 to 40 hours. Level 2 AC, 8 to 12 hours and 15 to 35 minutes with a level 3 charger. Next is bills of material. As you can see, we need many solar panel, which is 40 pieces, and then solar interior we only need 1 pieces, solar charger controller, and battery we need 10, EV charger type, and the EV charging cable. So the total is 28,935 ringgit and 5 cents. Flow chart. For the flowchart, the goal of creating a project flowchart is to guarantee that the project is headed in the proper path from the start to the finish. The flowchart begins with a meeting and conversation with the supervisor to gain a general understanding of the projects. The issue's description is formed from the debate and the project's goal is established. A few research are connective boiling are carried out based on the project objective. These studies are being conducted in order to learn more about the project's themes. The experimental equipment is then drawn in various different designs, and the final design is decided by referring to the defined criteria. So this is the flowchart, and this is the Gantt chart. So that's all from me. Thank you.
Assalamualaikum. My name is AHMAD bin AZLI, matric card number MH19042. I'm going to explain about chapter 4, result and discussion. Okay. On this chapter, this is the design concept. Okay, on the left side of the picture, this is the EV charger. Okay, and on the right side, this is the solar carport that has been chosen by us among 3 designs. Next, this is the final design concept. I draw this drawing by using solid modeling apps. Okay, on the left side of the picture, This is the final design solar carport. And on the right side of the picture, this is the top view of the final design, which is the solar panel. Next, this is the right view, and as we can see, there is the place of the EV charger. And the right side of the picture, which is the diametric view. This is shown the entire picture of the design that we have been chosen. And next, this is the orthographic drawing. There is the diametric view, the top view, the right side view, and we can see there is the dimension of the solar panel. I have drawn this drawing by using the AutoCAD drawing. Next, Chapter 5 Conclusion. Finally, we agree to create a project for electric car charging infrastructure technician staff based on the objective and scope that were established. This project is aimed to solve the challenge of employing more people while also making it easier for them to do so. With the help of our team members and supervisor, we chose the design for this project. It can teach us to accept the perspective of others through conversation, and we may develop a rounding machine to examine the roundness of wheels as a result of this combination of opinions. That's all from us. Thank you.